Okay, in this problem, we're given f of x is equal to x cubed plus 2x plus 3, which is all over x squared plus 1. And we want to find the first derivative of this function. And in order to do that, I'm going to use something called the quotient rule, which states that the derivative with respect to x is equal to the derivative of the top expression times the bottom minus the top times the derivative of the bottom expression. And then it's all going to be over the bottom squared. Okay, let's go ahead and identify the top expression as f of x, and that's going to be equal to x cubed plus 2x plus 3. And then the bottom function g of x is equal to x squared plus 1. F prime of x is then going to be equal to 3x squared plus 2. And your g prime of x is going to be equal to just 2x. And let's go ahead and plug it into the formula. So d dx is going to be equal to f prime of x, which is your 3x squared plus 2, times g of x, which is x squared plus 1, minus f of x, which is x squared, or x cubed rather, plus 2x plus 3, multiplied by g prime of x, which is 2x. And that's all going to be over g of x squared, which is your x squared plus 1, all squared. Okay, if we clean this up a little bit, d dx is going to be equal to, let's see, 3x to the 4th plus 3x squared plus 2x squared plus 2. That's all going to be subtracted by your 2x to the 4th plus 4x squared plus 6x. And that's all going to be over x squared plus 1, all squared. Okay, and let's go ahead and combine like terms. So we get d dx is then equal to 3x to the 4th minus this 2x to the 4th. So you just get an x to the 4th. And we can combine all of these x squared terms. So we get a 3 plus a 2, which is 5x squared, minus 4x squared. So you're just left with an x squared. And then you have a negative 6x and a 2 at the end. Okay, that's your top. And I'm going to go ahead and just write this as x squared plus 1 all squared. And that's it. That's your answer.